So since you understand trapezoidal rule, the Simpson's rule now says let's use tiny little parabolas to wrap even closer around the function we're approximating. So in Simpson's rule, it's a very similar process to trapezoidal, except now it's divided by 3.
Yeah, but if you want to say 3 in this.
And now the coefficients start at 1, and then they alternate between 2 and 4, and end in this pattern for 1. So for Simpson's rule to work, n has to be even. So that's the stipulation of the question.
So is there a way when we know when we're supposed to use?
It will tell you.
It'll tell you.
It'll tell you what to use.
So it always
So
starts.
then we won't
even,
have
you just
to
Simpsons with
know n is
these
even, you'll
problems.
just be able to know that it's Simpsons.
Right.
It'll say Simpsons rule.
Yep.
It's
Oh.
hard. That's
So let's take a look at this function at the bottom here. Okay.
Oh, okay.
So notice here you can't use u substitution because du would be 2x and we have no x here. So we're going to use n equals 4 here.
Okay. Got it.
And so let's go ahead and draw all the heights there. And if we split this into 4 equal intervals, delta x is going to equal, what's that? 0.25. Okay, so we're going to do the limits of 1 minus 0 over the number of subintervals, 4. So it's 1/4 or 0.25 either way. So now, when you get this, you actually have 0.25, 0.5, 0.75, and 1. And don't forget our 0 here. So now let's apply Simpson's rule. And remember, this one starts off b minus a over 3n. So it actually is 1 over 12. Okay. And now the first one is just f of x sub 0. So it's the square root of 1 plus 0 squared. The next coefficient is going to be 2. And now it's f of x sub 1. So it'll be 2 square root of 1 plus 0.25 squared. Next one's 4. So plus 4 square root of 1 plus 0.5 squared. Good. And then plus 2 square root of good 1.75 squared.
But I thought it had to have a 4 before it had a 1.
No, doesn't have.
So just plus 1.
Oh, what did we do wrong?
What'd you do wrong, Mr. Pyle?
I don't think we did
Maybe you wrote the sequence wrong.
You do anything wrong.
Coefficient pattern. Sorry, we found an error. It's got to go from 1 to 4 to 2 to 4.
Okay.
It was right here. 1, 4, 2. So just cross out that 2 right there. Sorry about that. I did the assignment correct, and I did my notes correct. I just messed up there. Sorry.
Did you make all of these?
I did.
Wow. A lot of time for this class.
It was a lot of time.
Thank you.
Appreciate it.
Okay, so you kind of got the process there. So it goes from 1 to 4 to 2 to 4 to 1. Does that make sense?
You have to put that in the calculator?
And then you'd put this in your calculator. And again, go to 3 decimal places there.
Calculator on your steak.
So you guys kind of see that the parabolas are going to get even closer. And a lot of times, with a lot of functions, the parabolas are actually equal to the curve. So it's kind of an interesting...
So how would how would you draw these parabolas, or did they just say it's parabola based?
You just draw it like that.
parabola.
So it's only a part of the parabola, not the whole thing.
It's like each one would have parabolas and cube.
All right, so your assignment is on Maolu.
I got it right, I got it wrong, 2 times in a row.
Yeah, 1, 4, 2, 4. Oh, writing it down that way. All right, say bye to Chelsea.
Bye, Chelsea.
Bye, Chelsea.